Welcome back to Science Hub. My name is Marian Bănică, and Science Hub is the place that connects you with the future. Today we are honored to have a special guest. Adrian Buzatu is a former researcher and data scientist at this moment. Good afternoon, Adrian. Good to see you.
Hello, good to see you, and thank you for the invitation.
Yeah. Adrian is basically a globetrotter. It has a lot of experience in multiple countries, including Romania, where he started his education. After that, he moved to Canada, to McGill University. After that, in Switzerland, at CERN, the research laboratory. In China, in Germany, and who knows where it's going to be next. So you are, it's our pleasure to have you as a guest, Adrian. I decided to have a practical approach on the topics that has the most interest at this moment in our daily life. So I decided to challenge you to discuss about data science in smart living. What do you think about this? Can we show to the audience the practical approach of data science?
Yes, thank you. Thank you for the invitation and the proposal of the topic. Indeed, I have a background in particle physics, where I was part of the search for the Higgs boson, this particle that gives mass to other particles. And basically, during that time, I developed the skills of what we call now data scientist in the industry or in the company in general, because it involves things like getting insights out of data, from statistics to machine learning, forecasts, optimizations, simulations, and in general, you need software to analyze the data at a bigger scale, so building pipelines. And in the end, these are the things that I currently work on in the industry, where I'm a data scientist in Berlin at TM Mobility, where we optimize the operations of our fleets, electric e-bikes and electric e-scooters. And that involves indeed forecasts and it involves optimizations. And I think these are in general problems that can be applied to so many use cases, including the part about smart living.
Mm-hmm. So you have a lot of experience in mobility solutions. Let's discuss about a part of, which is just a part of the smart living. I will challenge you to talk about daily activities at all, not just about the mobility. So let's start with the data science in smart living. Can you give us some examples specific that how data-driven insights can contribute to have a better understanding of our daily habits?
How data can help understand and then maybe improve our daily habits, right? And this starts exactly by the fact that now we can have more data than we had before. We have sensors that we can have with us in a watch at our wrist that can monitor health parameters or how much exercise we do, to sensors that you can put in your house that could monitor things from your energy consumption to the different tools that you use, to sensors you have in your car when you move around. And in general, we have more and more information around us, about us as well. So you can, in theory, collect this information and then analyze it and see some patterns. And that's what data science does, finds patterns in such data. And from that, you can make some recommendations, some suggestions, what they call data-driven actionable insights. And insights that are actionable can make your recommendation. For example, change this life habit that is not too healthy, like do more sport or eat less sugar, for example. And in theory, you can do that if you have enough data around the person's behavior. Yeah.
Mm-hmm. So basically, you can track everything nowadays that it's important for your lifestyle, right?
We have the technical capabilities.
Mm-hmm.
It's a question of several aspects. So one of them can be data privacy and security. Who do you trust to give this data to? Maybe they don't use it to sell you other products for marketing. Maybe you want to do it in a GDPR environment. So this is one thing. There are also things related to cost. Collecting this data, storing it in a cloud solution has some cost related to it, transmitting the data as well. And then if you start to analyze the systems, you need in the end a full data product that requires a database or a data lake. Then you have processes that run in the background that every day can learn from this and improve their models. Then you want to make forecasts, and you want to do it in a easy, cheap way. But if you have many people, customers or patients, then you want to be also scalable. And with scalability, you need very advanced engineering skills. And it's also things about optimizing the cost. So in principle, anything can be done. And as a data product, let's say manager, you would ask with your business stakeholders, what should you do and what you should not do to balance all these benefits versus cost versus time.
Okay, let's define a bit data, because it's a bit abstract term for everyone, and let's be a bit more specific to smart living in general, not to anything. So, what kind of data we can collect? Let's give us some examples, please. So, about health, what information from the health we can track in order to have a personalized or better understanding of our lifestyle, if it's healthy or not healthy?
Yeah, very good point. Health, we should monitor more, and we should act more regarding health. So we can start from a simple watch that can monitor how many steps did we do every day. This is the most basic element, right? And basically, it's a time series of how many steps you do in every day, and then you monitor this for a long time, and you see some patterns. Do you do enough? Is there a growing trend? Is there a stability? Has it fallen down? There are some big pauses. From walking, you can go to running. Then you can go to all sorts of different exercise, including how much cardio you do versus weight lifting versus in general movement. Then you can have some of these sensors that appear that you could even attach to your heart, and can measure things from an EEG that can measure your heart rhythm and identify in advance if you have some heart problems. Of course, you can have all these analyses that are about blood and about urine and others that can tell you about your inner metabolism. And usually people do them, let's say, once every few years. You could do them more frequently, and then be sure that you are on track. So in general, you can have all sorts of different KPIs that become variation in time. That is what we call time series. And you can identify if there are abnormalities or if there is a trend, right? So this is the most basic sort of analytics that you can do.
Mm-hmm. So basically, what you tell us is that we generate a lot of data. It's important how we track them, and also how we remove the noise, right? Because if you don't remove the noise, the final result, the final data result, are not going to be good enough. What can you tell us more?
Yeah, I think you raised the point what we call data quality, and indeed, this is the most important thing in data. So it's called data pre-processing, data cleaning. Just if you define the problem scope as we did, and you collect the data, you may find some problems. For example, some data can be missing, some data can be double counted, some data can be such at 100 times more than expected. Let's say if your pulse was 1000, you would realize, no, it cannot be, something is wrong. And it can be an error in your data processing or in your data acquisition. So skills like looking statistically at the data, understanding if this makes sense, if the average value and its distribution with the standard error around it are consistent with what you would expect. These are very important skills to have. And of course you want to automate, but you need to code that programs of computing and you need to also have some understanding of statistics to code that. And that ensures that in the end, you'll have a data that is good. There's a trend in data science called data-centric AI instead of just machine learning model-centric. So you don't just tune the model around data, you make sure you have the good data, and even a simple standard model can then perform quite well.
Yeah, so we have an image here that describes a few things that we can monitor from the health perspective. Blood pressure, everything basically. And at the end, if you have a digitalized solution that connects all this data in a single place, basically you can take decisions if you have to go to the doctor, if you have to ask a nutrition, and so on and so forth, right? So all these kind of things that we see in the image basically can be tracked, but these are just a few parts of the things that can be tracked, of course, right?
Yes, so you can build what we call a data product that every day may receive new information. Not every day you do a blood analysis, but every day you have the ability to add some new information there, and therefore the system gets updated every day, and every morning it can make you a recommendation. The recommendation most of the time is say, do nothing, just continue, but it can sometimes say, now it's time for you to do your regular check out of the doctor for every 6 months, or this week try to exercise more cardio. And this is what they call actionable insights, where it can suggest to you your thing. So you can get personalized recommendations by having this personalized data about you. And you have to put it in an environment that you trust to share your data with. And you can add in more data and get more advanced recommendations.
Mm-hmm. So also you can have a lot of insights on how to. So basically, it's a prediction of your health. So if you are doing the same, let's say, bad, and you still have the same bad habits, you should expect to go to a hospital one day, right? And all these data you can see, and you can take decision if you want to stop doing bad things in your health style, or improving your lifestyle, right?
Of course, yes. These are recommendations that you can act on. If you don't act on them, your health may depreciate. And this is the big issue, is like, are people acting on it? And this is what we also see in my work and in general. Like, we make some recommendations, and they may be good, coming from data, from artificial intelligence, basically patterns in past data, but it doesn't mean that people will necessarily act on it. And you need to convince that you can trust this number. So this is why, as data practitioners, data scientists, we also play the role of stakeholder management. So talking to our consumers, to our customers, to our clients, to the people who should act on this data, convincing them that this is better than the manual decision or no decision, and it's worth that they give it a try and they trust it. And that's why you need to measure uncertainties into this forecast, and also just in general evangelize data and data processes and statistics. That means educating people to think in terms of data, so that don't act just on their biases, but act on the data if the data contradicts the biases, the preconceptions that we have around. Like things like health are quite intuitive. People know they should do more sports and eat less sugar, and they don't. It's hard to, and it's still hard to convince them to give up on that. But sometimes in life, you have an intuition, and then data contradicts that. This is the hardest part, that you really have a belief system that you can update with new data, with new confidence.
Mm-hmm. Quite impressive. I mean, how technology can be used in order to improve our health and also our lifestyle. It's really impressive. And let's just tell to everyone that these kind of things that maybe are quite new right now on the market, they are not, they are very old in the research area, and also it took a lot of time to come here, right?
Yeah, there is a long time from fundamental research, like I did a CERN, to applied research, from applied research to engineering, and from engineering to actually building a product that it's very easy to use. And thanks to the advancement in computing power and also in electronics becoming smaller from a smartphone or from a smartwatch, and sensors of IoT that we can put around the house, or even the medical analysis that you can do in one morning and then by noon have the result because they are sent to a clinic, that you have the technology nearby, from telemedicine to just having more of these advanced technologies and clinics near you, you can get so many more insights. And we are in a fortunate period where we can have access to all this data and they can help us live a healthier life.
Mm-hmm. Let's discuss a bit also on this image about personalized nutrition and let's say patterns that you see in the daily dietary. What we can learn from the data about what we eat?
Now, you cannot really monitor exactly what you eat unless you have a camera in real time. But you could monitor quite easily what you buy for food, right? And you assume that what you buy, you kind of eat, right? And here I could imagine you can even scan the receipts from the supermarket, and then you already know what products, what quantities. You could even scan the labels on top of them, and then you know what content they had. And slowly you could build a database of what would be the quantities of fat and protein and sugar for different products that you consume, and then by knowing the quantities you bought, you could anticipate that thing. Or you could even do something simpler of like, if you only buy processed food, like for example salami, versus you only bought raw food that you prepared yourself in your own barbecue, which is more healthy. Relatively. So you can identify these patterns of buying, and from that you can do data analysis as well with clustering. And again, the challenge is technical wise, how can you do that so easily? But nowadays with the advancement also of computer vision, that you have these tools where you can scan a photo and you can transform it to text, and the text you can convert it to a table which has the products and their quantities, and then from that product from table you can have the you start analyzing it. And who knows, maybe data will bring you a surprise. Maybe you'll realize that actually buying healthier bio products, which are more expensive, maybe in the end it turns out to be cheaper. Because let's say you cut down on chocolate and all sorts of sweets, and now you get a better quality meat, and more vegetables and more bio products. And maybe overall you can prove with data that it's same cost or even cheaper while you live a healthier life. Because in the end, you need to eat a little bit less quantity, but eat it better. Mm-hmm. And maybe that can convince you in this direction.
Yeah, you know my example because I did on my own these kind of things, and it was really important for me to have the data in order to get off 50 kilograms in the last 6 months. So based on the data, I was able to take decision. And I want to show you some things about our next topic, which is automatization of daily tasks. That are very important also, and we have a video for this. It's a video that I did a bit earlier. Let's see it. Because maybe we don't have audio, maybe we can stop a bit. This is Pepper, and we are. I'm okay.
Thank you very much.
Once again.
Hi Pepper, nice to meet you.
Hi, nice to meet you too.
Tell me more about you.
I am Pepper. I am a robot designated to help people to get a smarter way of living.
You are part of the modularity team, right?
Yes, I am.
Tell me more about modularity.
Modularity is a smart home designated to be a mass product by 2030.
What it means a smart home?
First, it means an energy-efficient house that produces more energy than it consumes. Secondly, it means that it is multifunctional, which means that the same space can be used at the same time as an office and as a sleeping place. It also has robots like me. I can help automate any repetitive task which is not productive for humans.
What is your role in the team?
I am an artificial intelligence human companion. I hope you get more free time for you to invest in your hobbies.
Yeah, now it's much more clear. Thank you very much.
Yeah, so basically we saw Pepper, which is my office colleague, and this robot is able to take decisions mostly based on data, right?
Yeah, like if you have enough data input, you can make an optimization that can recommend from several possibilities the one that are more basic, the best for you. You can have some rule-based at first, and then you can do some more complex optimizations with constraints. A field that keeps growing, we call it operations research, and that can decide for you, for example, what food to order from various choices with your own constraints that you want to eat healthy food in a particular budget, in a particular quantity, for example.
What consideration we should be taken into account from your perspective to ensure that we have a responsible and secure implementation of data-driven automation in daily life?
So we want to automate decisions or recommendations, let's say, and then the human decides if to act on them or not. But already automate recommendations, it's a very, very big process. So we need to be able to collect the data, and we need to do it in a safe way that respects the privacy, like GDPR conditions. In Europe, when you put them on a server, that they only belong, only the person has access to them, and not other parties. But still be able to learn in an anonymized way across several people, so that we can train a model, that we can make a forecast and then optimize it. So we need to collect the data and we need to analyze it. So you need knowledge about statistics and machine learning implementation, but you also need the engineering skills to have these automatic pipelines that can ingest new data every day, they can make forecasts every day. And these are roles that are called analytics engineer, data engineer, and on the machine learning forecast we call machine learning engineer. So lately the engineering part is very, very important in the data science. And data science is more on the machine learning forecast, on the optimizations, statistics, understanding that, and basically putting everything together in what we can call a data manager, data product manager, or a data owner. And this is why the roles specialize a lot, and you need a team, and the team is called a cross-functional team, because you need skills from different perspectives. But you can start with a prototype that one person does. We call that a full stack data scientist, like just as you have a full stack engineer, like both back end and front end, you can do similar things with data. And the more senior you are, or the more impact you want to have easily in a small project that you start, that's what you can build a proof of concept, and you can build an MVP, a minimum viable solution, that you can present to your stakeholders, your management, your customers, and convince them to invest at a bigger scale. That's what you have to be as a data scientist to be able to build a small database and update it with some APIs that you query every day or from other databases. Then you want to be able to train this model. You want to put it in production in something like local or a VPS server or an AWS server. Be able to estimate roughly the cost. You don't want to, you may want to invest a little bit, but not a lot. So you want to think a bit like engineer to estimate this cost, and then you want to serve this model so the predictions to serve them in a tool we call Fast API, usually that every time it makes a query, it forecasts something, and then you want to show the result in a dashboard. So all these business intelligence tools, and that's why you need to do something end-to-end. Luckily, Python as an ecosystem does everything to show a prototype, and you can always go to better solutions like Power BI, Tableau, Looker, and others to show to the business stakeholders. You can also go to advanced solutions for the databases like Snowflake, that is very efficient, or Databricks. So there are all sorts of tools that come out, and as you scale the product, you may want to use some of these vendors that are specialized in this. But you should start small with a prototype you build yourself beginning to end to prove the value.
You said that we trained the model. Can you explain how we can train a model focused on the smart living scenario that we discussed right now?
Yeah, so training a model means learning from past experiences, from past data, and you can have two sorts of forecast. You can have a classification that separates between yes or no, good or bad. Should I go to the doctor today or not? This is a classification. So every day it gives you a yes or a no, and most of the time it's no until the moment when it gives you a yes. Or you can have a regression where you predict a continuous stream of numbers, like you can predict the price of an item or what is the demand of a product or the supply of a product, right? And usually, and then these are the type of tasks in the end. Then it's the type of tasks that comes in. If the data has a time order, we call it a time series. And then it's very important to keep the things chronologically in order so that you can learn from the past to predict the future. You cannot, if you learn from the future to predict the past, yes, you can predict, but it has no value. So you have to be really careful to not have this data leakage from the test data set to the train data set, because we divide into train, validation, and test. You train first, you learn first. Then there are a lot of values called hyperparameters that you can tune. And then you choose this tuning in the validation set, and once you fixed everything, you retrain one more time, and then you use it at non-seen data. And the non-seen data is the test, and then where you really evaluate the performance of the model, and then you choose a model that is the best. And later, when you put it in real time in production, you still need to keep monitoring to see that it still continues to perform well, that it doesn't diverge, it doesn't have a data drift. And this is roughly how we do the prediction. This is time series, you need to keep the order. If it doesn't have a time series component, like if you look at 1 million customers and then you want to see patterns to group them into categories, young versus older, how do they behave in their health parameters, for example, then time is no issue, and you can reshuffle the data, and you want to keep them the right percentages. If you have 3/4 of young people and 1/4 of older people, you want to keep the same proportion, 3:1 in both training and in testing, so that you have a representative data set. These are the considerations to have a good forecast. You also need to have a definition of what is your metric that you want to optimize, right? And they also vary from a regression to a classification. From a regression, usually compare the real number with the number you predict, the difference between what we call a residual. And on average, you want that residual to have a mean at 0 and the standard deviation at 1. So to be like a Gaussian distribution, very, very narrow. But in practice, you cannot optimize both at the same time. And you have a trade-off. It's called the bias variance trade-off. So basically, you can know something very precise. So you have a correct number, but then you can have an uncertainty that is not accurate enough. Or you have something that is very, very accurate, but then you're so a small distribution, but you're wrong by the central value. And in some way, this is very similar to quantum physics that I was studying before, like Heisenberg principle. If you know where something is, you don't know its velocity, so you have an uncertainty. So you know where it is, but by the time the velocity can be so large that by the time you thought about it for 1 second, it's already far away because it has a large speed. So it doesn't help you. And the opposite, if you measure the speed very well, you don't know where it is. So something like this bias of how far you are from the average value and how big you are, this uncertainty, so standard deviation and the mean, bias and variance are very real. And this is why there is a lot of subjectivity in choosing the working point. And you try to automate, you have to have some good practices, these right definitions, but in the end, models should be always verified and not just trust them blindly.
Mm-hmm. From what you tell us is basically that we can do some behavior prediction for smart homes, right?
Yeah, I mean, if you, for example, you look at time series, and if you run every day 5 kilometers, you could predict that you'll also run tomorrow 5 kilometers. That's one example. But you could also do things related to your home usage. For example, let's think a bit in terms of energy. If you have a solar panel, and that solar panel, produces energy, and you see the pattern from that, then you can estimate what production is for every hour. And then you follow your behavior, like when do you actually use the washing machine, and then when do you actually watch TV, and also maybe you do some sports, and that sport also consumes more electricity because you are somewhere in the basement and then you consume there. And then you can realize that and make some optimizations, and then you can say, well, at this hour I want to save this energy to the battery, and at this hour I want to put it into your saving, into your to actually use it. And then, oh, the washing machine should not start in the middle of the night when there is no sun. How about starting it at 2 p.m. when the sun is maximum, so that it doesn't go to either the battery, nor the consumption, nor back to the network. I want to go directly to use it. So you can optimize all sorts of things by seeing these patterns and then making the forecast. Including, you can say to a human to go out during the day. I mean, why work at night where you consume electricity and it's also not healthy for your eyes? Maybe why work during the day and then you save energy at night, because at night you're sleeping, which is also healthy for you and also good for the environment because you're consuming energy at the right time. Maybe people don't realize how much energy they could save just by waking up early at 6 a.m. when it's sun outside and they can work, instead of waking up at 10 a.m. and then working from 9 p.m. to midnight when they're working or watching TV. And they could switch the schedule earlier, which is healthy, but also consumes less energy, for example.
Yeah, quite nice. Let's move on to the smart home technologies that we already discussed, about solar panels, about how to produce energy and so on. Basically, there are a lot of IoT sensors that we can put in a house. And you know that in the house that I'm working in, I put it already 230 sensors in order to generate all kind of data. You have the database already. What can you tell us about IoT sensors that we put in the data in the house in order to to track all kind of things and from the data perspective?
So now it depends on what the person allows you. Again, GDPR to monitor and the cost related to that. All these sensors cost to build, to install. They consume a little bit of energy. But you can have all sorts of data, and if somebody is very open to that, then you can learn a lot of things. So some of them are about the energy consumption and production. Mm-hmm. If you monitor every individual item.
So we have an image here with what it can be monitorized, right? So let's discuss on the image.
All sorts of electronics appliances, right? Mm-hmm. Then you can monitor, if you put cameras, you can monitor all sorts of insights like how long you're in, when you're out, and the time of the day. You can monitor temperature in the house. You can put the window blinds going up and down, and then of course all the other health things are around the person. And including the energy production. So all of this technology is also very related to energy, because it's electric energy that enables us to even afford all these electronics that run in real time, including charging an electric car. That's a big component, having a battery, having an autonomy, so that we can put in the battery and not go direct to the network. And next time, so at nighttime, you have from your own, and you want to control. You want to start optimizing how these electronic devices go, and maybe decide by themselves when they start in and out. For example, you can have a small robot that cleans your house while you are away. Then you can have a fridge that could look inside and via computer vision. But maybe you can have other systems, like with some RFID or something that kind of knows you, because you ticked something, and you have some tags that you can use inside your house, and based on that it can know, for example, when your milk has finished, and then put an order online. Now you have all sorts of online delivery systems that in theory this robotic automation can send a delivery to the supermarket, who can make a delivery automatically to you, and maybe if you trust them, be left in front of your house without you being away, or have an automatic opening of the door just for you. And even if you say it doesn't have direct implication on health, but it just saves you time that you would have spent otherwise counting the milk in the fridge and going to the supermarket and coming back. This could allow you to relax, to do some yoga, to do a proper sport of running, 5 kilometers, which is half an hour and back, and therefore you're more relaxed and you are healthier just by doing that. So saving time can translate to better health, even if it's not directly your health by what you eat, but it's a big component of health, to be less stressed and you have more time to connect to yourself.
Yeah, as you know, Pepper, the robot that we saw in the video, is already helping me to reduce my repetitive tasks that are not relevant at all. Yeah, what other irrelevant tasks do you think that we can see from our daily habits from the data that we monitor?
Yeah, I mean, you can have, you know, things like cleaning or washing or you know, washing dishes, washing clothes. Of course, you still need maybe to put in inside the machine. The machine could start, you know, in a more automatic way. Charging your car. So actually, a lot of it is about bookkeeping, and it takes time. But imagine you just come from work with an electric car and you plug it in. Automatically, it starts charging it. But maybe it's the middle of the night when electricity is more expensive and you don't have energy from a solar panel. So how about you plug it in, but then the system decides by itself when it actually starts charging in a way that is optimum for your car, because it kind of knows from your pattern that you're only using it at weekend. So, it can afford to wait and charge a little bit on Monday during the day, on Tuesday during the day, and Wednesday during the day. And you trust it so that and if you always have an emergency, you have a little bit of battery there to go for 50 kilometers to the city and back, right? So if you learn these patterns, which is the forecasting time from your behaviors that we said, the system can learn when to charge your car, and then it can decide how often to clean your house, because it knows how often you clean in the past and can estimate from that. So I see a lot of opportunities to just automate human behavior.
Mm-hmm. So we have here an image of a smart home. Basically, on the screens we can see a lot of results of your work, the collection of data and how are displayed. So what can you tell about smart appliances or the data that are monitored by smart appliances in a smart house?
Yeah, they can collect a lot of data on you, but you also need to understand carefully what they do and what they don't do, and if they spy on you. So spying is a big issue, and European Union tries to be very careful around that and has some regulation. But in general, if you use them well, you can have all sorts of information from the window blinds that go down, from the cooking sensors, the temperature in various rooms. You can see if it's cold enough at night, it should be around 19 degrees, not too hot. But if you stay still at working, then it should be a bit warmer. Women need a little bit more temperature than men, but you live in the same room, so it's tricky. What is the right balance? So you can personalize and you can understand the differences, and then in the end, of course, you need to be able to monitor. And having an app like this that puts it all together, but it must be in a nice way, in a very efficient way, a nice user interface. So having this data product successful to become commercial, it's not just about the data, but it's about building an entire product around that to really have personalized recommendations and have user interface and actionable insights. So you need an entire team about user design and in UX, UI as well.
Mm-hmm. You mentioned something that is very, very important when we collect all this kind of data. It's about privacy and security and all these kind of things. Tell us a bit more on this topic, because it's very, very important for our listeners in order to understand that, privacy is important, but it can be, from my perspective, maybe you have, I want to see also your perspective, if we can keep track on everything that is related to the privacy of the data that we collect.
Yeah, to bring these benefits to people, they need to adopt it and use it. And to use it, they need to trust the data. So let's say there is the money, there is the computing power, but for somebody to allow to have such a camera that monitors you in real time, maybe through video filming, right? It's intrusive, and maybe it's important for you. Maybe you are old and you're predispositioned to fall, and if you fall and nobody around you, you would like this camera to detect and say, oh, now the person has fallen. Maybe there is a heart problem, and therefore call 112 by itself, right? So there is a very important use case, but you have to give away some of your privacy for that, right? And therefore, people need to trust that at least it's not others who look at this data. So as a solution builder, you need to make sure that the data is unique for every customer. It has a unique ID. It's not shared, and then the details become anonymized, and you have only this hash ID that keeps all these events to this unique person, and only in another database you can connect this hash ID to the details of the person. So whenever you do the data analysis, you don't need to know who the person is. Only when you do things like billing and charging and alerts to the hospital, then you need to know, right? And then also from a security of just the servers, they shouldn't be a hack into them. So you have to build a security team. And now there are more and more attacks online because a lot of tools are based on open source data, packages from Python, for example. And you call a package that calls another package that calls another package that is some logging that everybody uses. And that's how an attack was a few years ago from a Java package about logging, and that affected a lot of computers worldwide. So it's more and more important to also help the open source community that we rely a lot, including in the businesses. Paying businesses also use open source packages to make security along the way. So this is one thing. And then the other thing is the GDPR guarantee by strict protocols that nobody else will have access to your data, unless it's just anonymized to train the models. But the recommendations are just for yourself, and nobody else than you knows about this, or the people you give access to, your doctor, your close family. And it can be done, but it is some cost that must be taken into account when planning such products.
Yeah. Let's talk about future trends in smart living from the point of data from the data point of view. Tell us, based on the current developments, what emerging trends do you see in the market?
A big trend is this generative AI, large language models for text that makes easier to interact between humans and machines, right? Mm-hmm. They're not necessarily doing the forecast of demand and supply or the optimizations, but it can make it easier to just communicate with these machines, right? So you can ask a question like, when do you think I should go to the doctor next time? And this LLM model can query the data that it knows about you and then reply in English, in other languages. I think the next time should be in 3 weeks, right? And having this dialogue makes it easier for humans to relate with the machines instead of just saying a number in a dashboard. And then you can also give some orders to your machines. Open the blinds, start the cleaning, right? And then we have solutions from big corporations around this. But when you do more, then you can have this entire human-machine interaction that makes it more livable, and then you can connect better and relate better. So I think this is a big trend, this interface between us and the machines. Other than that, the data will become bigger, the solutions become so they were very complex, a lot of patches of different solutions for engineering that take a long time to build, to maintain, and scalable. And there are more and more solutions that do something integrated for you. That's one direction. The other direction is to simplify. So yes, it's about engineering, and the engineering will become more streamlined and easier going forward. And it requires people who are experts into this. But to really have success, you need this engineering, you need the data, then you need the statistics to train. And all of them are becoming bigger and better. So this is a positive trend.
Mm-hmm. In your opinion, what are the challenges that needs to be addressed to fully realize the potential of smart living through the data science?
I mean, we need to start small, right? With small prototypes that work. In general, to make us successful, you need to start with a proof of concept, then an MVP, minimum viable product, and then convince a group of target audience to use it, and then demonstrate and iterate continuously, right? So you need to build confidence. This is the biggest challenge. People need to give you access to their private data, but also to, if it's a question of cost, to even pay for all these sensors, right? So they need to see the added value. You need to start with some use cases that make it very successful. For example, saving people's life by detecting when people fall, when they are old, or make their orders for them so that they can directly know when there's no more food in the fridge and order from the supermarket. And therefore, we can do it. But we need to start small and demonstrate, and then improve on it. But build already with a scale in mind, so that you say, well, what if this is successful and I get 1,000 customers? Can my system that collects data still hold it? Can I have the security in place to store this data in a way that it is compliant with the GDPR and just the rules of the European Union? You have to know the regulations in this field, especially around health data, and also things about energy. There are incentives, there are discounts. You could even earn money from this if you install the right solar panels. Not just that, but it is heat pumps in the ground, or even a wind turbine, and everything has to be together to work. You need the energy, and you need the data, and you need the computing, and that should be fast enough. So you have to know what the trend is, including from the political and economic incentives, and then just start small and grow and build more and more.
Mm-hmm. Let's have a last image with what we can monitor, and please let's take some conclusions. Is the first image, yeah? Okay.
So I think it's a big trend. I mean, I'm a practitioner of data coming from a physics background. I'm quite excited about what data products have evolved and be able to produce in the last 10 years when it was not very common. But now it's more and more and bringing value in all sorts of basically everywhere, in all industries. You can optimize processes, you can save cost, you can save time, you can replace repetitive tasks from humans, that they can focus on more things that are more creative, more added value, find solutions that machines cannot do. It's not intelligent in the sense of artificial intelligence. It's looking at patterns in statistical data in the past or in similar situation. And then you can identify in a similar situation what it would do. And if it's an unknown situation, you identify that and you say, I will ignore such a data. So overall, there is a big progress that has been made theoretically in computing. There are a lot more people trained now in data science. There are even master's degrees at the universities. People do PhDs as well for more advanced topics. There is more people working in the market. So good companies could hire them and grow and build teams so that in the end, they define their own business case, they define their own business KPIs and build their own data products, which includes engineering, so collecting this data, having the sensors, collecting the data in a trustful manner, secure manner, then analyzing the data to find patterns, but the pattern should come from the business. What is the questions that we want to answer? Mm-hmm. This is really important. And then you can build it step by step and you see your impact and you keep growing.
Yeah. As a conclusion, thank you very much, Adrian. It was my pleasure to have you as a guest to Science Hub. I hope that right now we have a better understanding about what is smart living at the end of the day, and that smart living, it's also very related to data science. And yeah, if you want to start small, and after that grow. We've been now to Science Hub. Adrian was with us. Adrian Buzatu was with us. Former researcher and data scientist. My name is Marian, Bănică, and I hope you enjoyed a new edition of Science Hub. Till then, have a nice day.